Hello, and let's get started. So today's topic will be about public goods and the treasury of the commons. As usual, we will review the key concepts before going into the discussion questions. So let's start with the classification of goods. And we have two dimensions here, rivalry and excludability. So rivalry is talking about a person's consumption will reduce the amount available to others. So let me make up some examples to illustrate the idea here. So imagine an apple, okay? An apple is rival in consumption because let's say if there are 10 apples out there and you eat one of them, then there are only 9 apples left. This means that your consumption of this apple would reduce the amount of the apples available to others. So this shows that apple will be rival in consumption. However, let me make up another example that is non-rival in consumption. Let's say my tutorial notes here. Okay, so even when you are reading the words on my tutorial notes, the words are still out there, right? So when you're reading the words on my tutorial notes, other students or other of your classmates can still go through the content. So this means that the tutorial notes here is non-rival in consumption. It will not affect others' ability to consume this good. Okay, so the second dimension is excludability, and it's saying not costly to prevent others from consuming the good. Again, using the example of that apple, so it is excludable in consumption because if you do not pay the price of that apple, then you cannot consume or eat that apple. So it is easy to exclude you from consuming that apple. Well, let's say non-excludable in consumption, using my tutorial here as an example. The online tutorial here is non-excludable in consumption because I basically cannot check whether you belong in the course of Econ1210, right? If you get a link, then you can just stay here to listen to my trash talk, right? So this shows that my tutorial is non-excludable in consumption, or at the very least, it is very costly or time-consuming for me to check whether you belong to this course. Okay, so these are some examples that illustrates the dimension of rivalry and excludability. So at the bottom here, I put down the note. Sometimes there might not be a clear cut on whether a good belongs to a particular category. So what does it mean? So let me use an example of public road. Some people may argue that public road is a public good, while some others may argue it is a common resource. So for those who argue public road is a public good, they may think that it is non-rival and non-excludable in consumption. It is non-rival because even when the car passes through the public road is still out there, right? So it would not affect others' availability to use that public road. And it's also non-excludable if the public road is free to everyone, right? So this is one perspective. While some others who argue that public road is a common resource, they may think that the public road is rival and non-excludable in consumption. Why is it rival? Because they think that, oh, if we're considering public road during peak hours, then there will be a lot of cars inside the public road and it's very congested. So you may not be able to enter the public road during peak hours. Others' ability of using public road will be affected if the public road is very congested, right? You cannot even enter the public road. So this is why some people may argue that public road is rival in consumption during peak hours. As you can see, a good can belong to different categories. So this is why I would like you to apply arguments reasonably to arrive at the answer. So the next thing to go through is about the treasury of the commons. Private goods can be efficiently provided in competitive markets, except there is externality. But in this chapter about public goods in particular, it may be more efficient for the government to provide them. And there are two reasons for that. The first one is more difficult or costly for private firms to exclude non-payers from using these goods. So imagine the example of street light. Okay, so if street lights services is provided by private firms, and then they may say that, oh, when there are some passerbys using the road at night, then you need to pay me certain amount of money because you're using the street light. As you can imagine, it's quite impossible, right? So how can the private firms charge each passerby for using street light services? So this is why it would be hard for private firms to provide these kind of services, and it will be more efficient for the government to do so, as passerby would simply not pay the price to use a street light, and this caused the free rider problem. Okay, the second reason is that the goods can bring the greatest benefit to society and thus a larger total economic surplus. So again, using the street light as a demonstration, the individual benefit of using a street light will be rather low compared with the cost of building the street light. But if we consider the benefit of society as a whole in using a street light, the benefit will be much greater. So this is why trading of the commons would be an externality. Right, and at the bottom, we have some solutions to tackle with the problem of treasury of the commons. So the idea is that if you like to increase the consumption of production, then you just use some tools to incentivize that, like subsidization. While if you would like to reduce the consumption of production of the good, then you just use some tools to demotivate the consumption of production. Let's say regulation and taxation, something like that. Okay. And the final thing to review would be about vertical aggregation to derive the marginal social benefit curve. So to obtain the marginal social benefit curve, it is summing up the marginal benefit of the first person plus the marginal benefit of the second person plus the marginal benefit of someone else. So as you can see, we are summing up marginal benefits, which is expressed in terms of prices. So this relates to the first remark where we sum up prices instead of quantities to derive the marginal social benefit curve. So this is different from the technique we have learned in chapter 3 about the derivation of market demand and supply. In that chapter, we learned about horizontal aggregation where we are summing up quantities to derive market demand and supply. But here, to derive marginal social benefit curve, we are summing up prices instead. We are doing vertical aggregation. So don't mix up the two techniques in the derivation. If the question gives you quantity as a subject in the marginal benefit curve, then you need to do the change of subject expressed using P as a subject first before the derivation of the MSB curve. All right, so the second remark, if individual MB curves have different x-intercept, then the MSB curve would kink. So let me use the graph here below to demonstrate the idea. And let me say that this one is the marginal benefit of John, and this one is the marginal benefit of Steve. Okay, if the quantity is now quite low, okay, at this level, then both John and Steve is perceiving the good at a positive value. So this is why the marginal social benefit would incorporate both the individual benefit of John and the individual benefit of Steve. However, when the quantity is large, let's say at this level, then only Steve is perceiving the good with a positive value, but not for John. And this is why the marginal social benefit curve would only incorporate the individual benefit of Steve when the quantity is large. Okay, and as you can see, across different quantities here, the marginal social benefit curve have different expression, and this is why the MSB curve would kink at some point if the two individuals have different x-intercept for their individual MB curve. All right, so that's all for what I'll review, and we'll move on to question 1. Please take a look first. Okay, so to find the efficient number of street lights, we'll apply the MB equals to MC rule to find out the answer. Right, so what is the marginal benefit of installing the street light? Since there are 15 residents, and each of them is willing to pay $10 for each additional street light. So this is why the marginal social benefit of an additional street light would be 10 times 15, which is 150. While the marginal cost of building a street light, nothing special, it would be 2x directly given the question. Okay, so we just equate the marginal benefit 150 with the marginal cost of 2x, then we will have the value of x, or the efficient number of street lights, 75. Okay, so that's for question 1, and we'll move on to the next problem. Please take a look first. Okay, so let's start with question 38. If pollution is unregulated and negotiation is impossible, what would be the untreated wastewater that factory X would discharge? So because to treat the wastewater, it incurs certain amounts of cost, right, related to the n square here. So if pollution is unregulated, then factory X would just choose not to treat the wastewater and just discharge everything. So this is why factory X would discharge all 10 tons of wastewater every day. Okay, so this question 38. Well, for question 39, to find the socially efficient amount of wastewater to be treated. So it will actually be the cost and benefit analysis of society as a whole. So the benefit side of treating wastewater is to reduce the damage to nearby residents, given by this number 17.5, while the cost of treating wastewater will be related to the n square here. Okay, so n squared is about the total cost of treating wastewater. So this is why we need to construct a marginal cost table to compare with the marginal benefit 17.5. And let me take this opportunity to shift my screen to Excel to you and to calculate the table with you. Okay, let me clear everything here. Let's start with the first column, n, okay, and then the first one unit is 1, and then, okay, this one, cell plus 1, okay. And just pull down this one to obtain the whole column, okay, from 1 to 10, because we have 10 tons of wastewater. Right? So how about the total cost? It is n squared, right? The total cost of treating wastewater. So 1 times 1. And since this logic applies to all remaining cells in this column, then we can just use the shortcut key, Control plus D for down, or just to pull down to obtain the whole column here. And yeah, this would be the total cost of treating wastewater. While for the marginal cost of treating wastewater, for the first unit is simply 1. Second unit onwards, it will be current unit minus the previous unit, right? The marginal cost of treating the second unit of wastewater would be total cost of treating 2 units minus total cost of treating 1 unit, okay? And again, this logic applies to all remaining cells in this column. Then we can just use the shortcut key, Control plus D for down, or to pull down to obtain the whole marginal cost column. Okay, and we are now ready to conduct our analysis. As far as the marginal cost of treating wastewater is lower than the damage to nearby residents, 70.5, then it will be socially efficient to treat that ton of wastewater. And as you can see, up to the 9th ton of wastewater, the marginal cost is still lower than 17.5. So this is why it is socially efficient to treat 9 tons of wastewater. And finally, question 40, to achieve the socially efficient outcome, what will be the amount of tax to attain this outcome? It will be the cost and benefit analysis of the firm this time. Okay, so the benefit of treating wastewater is avoid paying the tax T that we're going to find, while the cost of treating wastewater is the marginal cost of treating wastewater from this marginal cost table here. Okay, so to induce the firm treating 9 tons of wastewater, the tax has to be at least 17, such that the firm would reduce the 9th ton of wastewater. However, the target is to treat 9 tons of wastewater, but not the 10th ton, right? So this is why the tax cannot be too high. Okay, cannot reach to 19, or else the firm will treat wastewater more than the desired level. Okay, as we have learned in the previous chapter, the tax cannot be too low and cannot be too high to attain the desired target. Okay, and anyway, the minimum amount of tax is 17. Okay, and yeah, so please take a look at the next problem first. Okay, question 49 requires us to derive the total marginal benefit curve, which is simply the marginal social benefit curve. So how can I do that? We need to check the x-intercept of the individual MB curve. For Adam, the x-intercept will be 60 divided by 1.5, while for David, the x-intercept will be 40 divided by 5.5. And apparently, 40 divided by 5.5 is a small number. This means that if the diameter is smaller than 40 divided by 5.5, then we need to sum up the individual MB expression of Adam and David to derive the marginal social benefit curve. While if the diameter is large enough, greater than 40 divided by 5.5, then David is no longer perceiving the fountain with a positive value. Only Adam does. So this is why we only put the individual benefit expression for Adam when the diameter is greater than 40 divided by 5.5. Okay, so referring to the GeoGebra screenshot here, when the diameter is small, then the marginal social benefit is the combined expression, while if the diameter is large, then only the individual MB expression of Adam for the marginal social benefit curve. So the yellow king portion is actually the marginal social benefit curve in question 49. We just map the points A, B, C in the screenshot here, then we can answer the question here. We have the marginal cost of producing the fountain in question 50 and 51. Okay, and we are going to find the socially optimal diameter of the fountain. So simply the intersection with the given MC curve and the marginal social benefit curve that we have just derived. Okay, so in question 50, where the marginal cost is 32, then we just draw the line y equals to 32 and find the intersection with the MSB curve that we have just derived. Okay, so intersection point would be the socially optimal diameter, 18.67. When the marginal cost in question 51 is 30 plus 0.1d, okay, we just find the intersection between the marginal cost with the derived marginal social benefit. Then we have the socially optimal diameter to be 17.5. Okay, so that's all for this one, and we'll move on to the next problem. Please take a look. Okay, so question 48, if villagers make decisions individually, what will be the number of trees to be cut down in equilibrium? So we have two activities here. So the first one is to cut down trees, and the second one is to participate in village work. Okay, so we are going to compare the income of these two activities for question 48. So as far as the price of each tree given by this expression is greater than or equals to the income from village work 460, then the villagers will just go to cut down tree. Okay, so this is why we are going to solve this inequality. And we have n is more than or equals to 154.5. And since n is an integer, this means that the equilibrium quantity of trees to be cut down is 154. How about question 49? The number of trees to be cut down from the society's perspective. Actually, we need to construct a marginal income table. But here, because there are 200 villagers, right? If you are trying to calculate a marginal income table in Excel, then it will be involving many rows, right? So this is why I would like to use an alternative approach, right? Pretend that the total income function is continuous and to express everything in this function first. Okay, so let me go into the details to illustrate the idea. Okay, so if we can express the total income function, then we can just find the maximum point, solve the solution. Okay, so how can we find the total income function? It would be the price per tree multiplied by the number of villagers who cut down tree plus the income from village work multiplied by the remaining villagers who go to village work. Okay, so this is the total income. And after some simplification, we have the total income function to be this expression. And it's a quadratic function. This is why we can find the maximum point to solve the solution. Okay. All right, so remember what we have discussed in chapter 6. Okay, in that chapter, I introduced the four methods of unconstrained optimization to you. Okay, so we are going to apply the techniques here. Okay, the first method is to use GeoGebra. What we need to do is to type the quadratic function directly in GeoGebra and then to find the maximum point. And as you can see, the total income is maximized at n equals to 77.25. And be aware, using this method of finding the maximum point, we need to do a little bit of checking because the number here just serves as a guide to the answer. Specifically, because n can only take integer values, so this is why we need to check the integer around this 77.25. In particular, check the total income at 77 and 78. If you put n equals to 77 and 78 back into this total income function, then you should be able to calculate the corresponding income at these 2 points. And apparently, the income at n equals to 77 is larger, and this is why the socially optimal quantities is 77. Right, so let me still briefly explain the remaining three methods of unconstrained optimization. Method 2, excess of symmetry, which is saying that the maximum point of the quadratic function attains at negative b over 2a. So we have the same number, 77.25. And method 3, completing a square. We just express the quadratic function in the vertex form, and we have the optimal n, which is also at 77.25. Method 4, using differentiation, then we just differentiate the total income function with respect to n, then we have this thing. By applying the first order condition where the first derivative equals to 0, then we are able to solve the optimal n is 77.25, again the same number. And in any case, using whichever method of unconstrained optimization, we need to check the n around this number, okay? Because this method only serves as a guide to the answer. Okay, you need to check the integer values around this 77.25. There's a caveat to you. Okay, and for question 50, if the government wants to impose a per unit tax T to induce the market to the socially optimal number of trees, then what will be the range of values of T? Okay, because the optimal number of trees to be cut down is 77. This is why we want the price per tree net of the tax is still greater than or equals to the income from village work 460 when n equals to 77. However, the optimal n is 77, not 78, right? So this is why we want the price per tree at n equals to 78 net of the tax is smaller than the income from village work, 460. So we have two inequalities here. So what is the P function here? Okay, the P function is actually the expression that is given directly here, 3,550 minus 20n. We just plug in n equals to 77 and 78 here, then we will be able to obtain the price per tree here, as I've highlighted. Okay, so solving this compound inequality, we will be able to solve that the t has to be between 1,530 and 1,550. Finally, question 51. If there's an implementation cost C for the government to implement any policy, what would be the value of C such that the government would still implement the policy? This time, it will be a cost and benefit analysis of the government. The benefit of implementing a policy is to increase the total income of all villagers from the market equilibrium point to the social efficient point. While the cost of implementing the policy will be the C that we are going to find. Okay. How can you find the increase in total income of all villagers from the market equilibrium to the social efficient point? Okay. So we have derived the total income function as this thing. Okay. So we just plug in the market equilibrium quantity 154 inside the total income function. Then we have the total income of all villagers at the market equilibrium. In addition, if we plug in the social efficient quantity 77 back into the total income function, then we have the total income of all villagers at the social efficient outcome. So the difference between these two numbers would be the increase in total income of all villagers, the benefit side of implementing the policy. And as far as the implementation cost C is smaller than the increase in total income or the benefit of the policy, then the government should still execute the policy. Okay, so we have C to be smaller than this number, okay, the increase in total income of all villagers. Okay, so that's all for this problem, and we'll move on to the next one. Please take a look. Okay, again, to start with, we are going to find the number of steers to be sent if residents make decisions individually. They can only choose to invest or not to invest. Okay, so as far as the profit for each of them is greater than or equal to 0, then the resident will just invest in steers. Okay, so this is why we are going to solve this inequality. And effectively, we have the market equilibrium condition is to invest in steers as long as the average profit is greater than or equal to 0. And solving that, we have n smaller than or equal to 5.1. And since n is an integer, then the market equilibrium number of steers is 5. Okay, so question 49, to find the socially optimal number of steers. So this time, we are going to apply the socially optimal outcome, which is to continue investing in steers as long as the marginal profit is greater than or equal to 0. Or effectively, we are finding the point where the total profit is maximized. Okay, so how can we do that? Now we are going to shift to Excel again to calculate the marginal profit table together. Let me again clear everything. Right. So let's start with the first column, the N column. Okay. First cell is 1, and then the second cell will be the previous cell plus 1. Okay. And then we can just pull down until 100, the number of villagers there. Okay. So we have the first column. And the next column, the average profit. So how can we find that? It can be found using the expression here, 25.5 minus 5n. Okay. Multiplied by 1 for the first unit. And again, for the remaining units, we just use the shortcut key, Control plus D for down, or to pull down to obtain the whole column. Okay, so there's an average profit. Well, for the total profit, it will be the average profit multiplied by the number of n. Okay, again, we can just pull down to obtain the whole column. And finally, the marginal profit for the first unit is simply 20.5, while for the second unit onwards, it would be the current unit minus the previous unit. Okay. And since this logic applies to all remaining cells, you can also pull down to obtain the whole marginal profit column. Okay, so we are now ready to conduct our analysis. As far as the marginal profit is greater than or equal to 0, then the residents should continue to invest in steers. So this is why the optimal number of n is 3. Okay, the marginal profit is still positive, but not for the next unit. Okay, so this is question 39. And for question 40, if the government is going to impose a tax to the steers, what will be the range of values of the tax such that the social optimal outcome can be attained? Again, we want the profit of each resident net of the tax for the third steer is greater than or equal to 0 to attain the socially optimal number. But because the optimal n is 3 but not 4, so this is why we want the profit of the fourth steer net of the tax is more than 0, such that the fourth resident will not invest in steer. So this is the second inequality. All right, so for the profit function, it would simply be 25.5 minus 5n, okay? Just plug in 3 and 4, and we have the expression here. Solving this compound inequality, we will have t to be between 5.5 and 10.5. And finally, question 41, to find the marginal external cost incurred by the Qth steer, where Q is the social optimal number. Because we have found that the social optimal number is 3, right? So we are going to find the marginal external cost incurred by the third steer. So referring to the table here, if the number of steer is originally at 2, the two residents can earn a profit of 15.5 for each of them. But when the number of steers increase from 2 to 3, average profit of each resident would reduce from 15.5 to 10.5. So this means that when the third resident decides to invest in steer, it would cost the first two residents to reduce the average profit for $5 each. So this is why the marginal external cost incurred by the third steer will be $5 per person multiplied by 2 affected residents. So marginal external cost is 10. Yeah, so that's all, and we'll move on to the next problem. Again, the first part, if residents make decisions individually, what will be the number of residents using public hospital? So residents will choose to go to a public hospital if the full cost of using public hospital is smaller than the full cost of using private clinic. Right? What will be the full cost of using public hospital? It will be composed of two parts. The first part is the waiting time in the public hospital, 3n plus 8 minutes. And since the opportunity cost of time is $20 per minute, so the first component is 3n plus 8 multiplied by 20, the waiting time in the public hospital. The second component would be the transportation time, okay? 10 minutes of transportation multiplied by $20, the opportunity cost of time. So this would be the full cost of using public hospital. How about the full cost of using private clinic? It will be composed of two parts as well. The first part is the charge 1,030. And the second part is again the transportation cost, 10 minutes per resident and $20 per minute. So we have 10 times 20 again here. Okay. So solving this inequality, we have n smaller than 14.5. Since n is an integer again, so the equilibrium number of residents using public hospital is 14. All right, so question 44, society's perspective. How many residents using the public hospital in this case? So we are going to find a point where the total full cost of all residents is minimized. Okay. So how can I do that? The total full cost can be found as follows. The number of residents using public hospital multiplied by the time cost of each resident who use public hospital. The underlying thing here is actually the underlying expression explained in question 43, the same thing, the full cost of using public hospital for each resident. Okay, and let me continue. And then plus the total time cost of people who use private clinic. Okay, 30 minus n remaining residents who will use private clinic multiplied by the cost of using private clinic for each resident. Okay, again, the underlying blue thing here is the same expression in question 43. After some simplification, we are able to obtain the total full cost of all residents is this quadratic expression. So we just plug in different values of n to check at which value of n the total full cost is minimized. So as you can see in the Excel table screenshot here, when n is 7, the total full cost of all residents is minimized. So this is why the socially optimal number of residents is 7. Okay, so question 45. If there's a charge of $600 by the public hospital, what will be the number of residents using the public hospital when residents make decisions individually? So we will build on the inequality derived in question 43. Now, everything is the same, just that there is a charge of $600 by the public hospital. Then we just add 600 into the full cost of using the public hospital. And this would essentially be the inequality I have put down for question 45 here. Okay, solving this, we have n smaller than 4.5. And again, n is an integer, then the equilibrium number of residents using public hospital is 4. Finally, question 46. If the government wants to give residents a subsidy who use private clinic, what will be the value of S such that the social optimal number of residents using public hospital can be achieved? Because at the social optimal outcome, we want 7 residents to use public hospital. So this is why we want the full cost of using public hospital for the 7th resident is still smaller than the full cost of using private clinic, taking into account the subsidy. Okay, so plug in n equals 7 and to take into account the subsidy. And this will be the first inequality that we would like to solve. Okay, the thing I have put down here. All right, because the optimal n is 7, but not 8. So this is why we want the full cost of using public hospital for the 8th resident is larger than the full cost of using private clinic, taking into account the subsidy S. Okay, so now instead of plugging in n equals to 7, then we put n equals to 8, and then swap the inequality sign and to take into account the subsidy. And we have the second inequality here. Solving this compound inequality, we'll have the range of values of S between 390 and 450. Okay, so that's all for what I'd like to cover in this tutorial today, and it will be the time for the attendance exercise. So I will open sets B and C for you, 5 minutes as usual, and I'll close the quiz at 9:21. Thank you. Two minutes left for the attendance exercise. And actually, I see most of you are quite quick. So if some of you completed the attendance exercise and have nothing to ask afterwards, you are free to leave actually. Okay, so time is up and I'll close the quiz soon. Yeah, so thank you very much for joining the tutorial, and if you have any question, as usual, please stay behind and ask them. Goodbye.